Hello there, friends and neighbors. I am going to show you now how to do linear regression, specifically simple linear regression. That means you only have one predictor. I've already answered the questions, but if I hypothesize that hand is linearly related to nose, what technique do I use? Well, that's a correlation. I use correlation for that. If I want to use hand to predict the values of nose, then I use regression. So what does regression give me that correlation cannot? Regression lets you make predictions. That's the difference. That's what it does. The assumptions are somewhat simpler for regression. We're assuming only that y is normally distributed, whereas correlation assumes that both have a bivariate normal distribution, sort of like a cone shape in 3 dimensions. But the main purpose, the reason we use regression is because it lets me do predictions. Okay. Analyze the real data homework for the first day of class. I'm going to conduct a regression analysis to predict nose from hand. Okay. So I've already got the data set open from the previous questions. That's what I'm going to do now. Statistical analysis, continuous variables, linear regression. I'm going to predict, my response variable is nose, predicting that from hand. And then I click OK. Now it drops me off at a bunch of stuff that I don't look at for an introductory class. I have to scroll up to get to the good stuff. The good stuff is I need to get the intercept and the slope. So the intercept, the b0 parameter, is right here, negative 540.75. I'll call that negative 540.8. For hand span, it's 31.9 is the slope, so 31.9. And that's that, and that's close enough. It'll mark that as correct. Is it a good model? Well, I need to do a t-test to answer that question. I get a hypothesis test for the slope of the intercept equals 0 or not equal to 0, and I get a similar hypothesis test for the intercept. Nobody cares about the intercept, so it doesn't matter. I'm only going to look at the hand, which is the slope. The only reason it's a slope is because this is simple linear regression. If I had more than one variable, we couldn't interpret it as a slope. But it's a weight, it's a b weight, and it tells me whether or not this is statistically significant. So 7.053, I guess I'll call it 7.05. Degrees of freedom are given down here where it says residual standard error, 47 degrees of freedom. 47. The p-value up here again is very small, so I'm going to copy it. Paste it, and you might notice at this point that the t-test is exactly the same for the correlation, simple linear regression, and bivariate correlation. They have the same t-test, and that should tell you something. The slope, if you have simple linear regression, only one predictor, the slope test is the same as the test for Pearson's R, the same as the test for rho. So beta 1 and rho have the same hypothesis test. But we've got something else with regression we consider, which is R squared, the model R squared, which tells me the strength of the percentage of variance that's shared between the two variables. So a multiple R squared is 0.5142. 0.51 is sufficient. That means 51% of the variance is overlapping between these two variables. So is this a good model? Well, 51% of the variance can be explained. I can explain 51% of your nose length just by knowing your hand span. That's pretty good. Furthermore, the beta 1 is not 0. We reject the null hypothesis and conclude that that weight is significant. It's not 0. So yeah, it's a good model because both of those things are sufficiently met. And you say that, type it up, I will read it, I'll give you feedback on it. Last question. Is this an actual prediction question? So in question 8, you computed this model, and I'm going to just spit back the model that I got for my convenience. It's here. So negative 540.8. For this, I'm going to use a spreadsheet. B0 and B1. Let's make that bigger. Okay. B0 and B1. Now, B0 we decided was, let's go back to the output, so negative 540.8. Negative 540.8 is what I put, and 31.9. And I know it's correct because it gave me a green box. So I'm going to get my x, my fixed x value is, if that model is correct, then you're ready to answer the next question. If someone had a hand span of 19 centimeters, what would their predicted nose length be? Well, y hat is equal to b naught plus b1 times x. So I predict it to be 65.3. And that's my prediction. I click submit. Marks it as correct. I declare victory. All right, let's see you for the next video.